Hello, I'm Chuck Martin, and welcome to the Voices of the Internet of Things. With me today is Ken Karklin, Chief Executive Officer of Pivotal. Ken has been an R&D project manager at HP, Vice President of New Products and Applications at Advantest, and Senior Vice President and Chief Operating Officer at AeroVironment. At Pivotal, Ken is focused on moving the company's flying vehicle operations forward. Welcome, Ken.
Good morning, Chuck.
So you're out in sunny California where you can actually test these things all year.
Well, that's certainly one consideration is the number of flyable days per year, and we certainly have a lot of them in this neck of the woods.
So Pivotal is one of the very longest ranging companies. Your company started in, 2011. That was like way before anything was going on. Can you take us through some of the history, like why that early and then why now?
Yeah, so the company got its starts in Ontario, in Canada, where the founder Marcus Lang had put considerable effort into developing a eVTOL, a winged eVTOL, that he actually built and flew on his farm personally, as his wife and neighbors looked on.
Back in 2011?
That was in October 2011, and that's
Wow.
kind of where the company got its start. He formed a company called Skycar, and his first employees were, up there in Canada. And it got the attention of some interesting investors in Silicon Valley, and they agreed to fund the company. They wanted to move it to sunny California, where it might be a little easier to find software engineers, and they'd have places that they could fly year round. And that's how they made the move to California. And then it was incorporated as Opener. I believe it was Opener Incorporated at the time, and then the company started growing. And so Marcus continued to lead the company for about, all in over 10 years, through 4 generations of vehicles. And we're counting that very first one that he built on the farm in Ontario as kind of our generation 0. Then came the first Blackfly, which was really a test bed for the propulsion systems, which they were building in-house. So they had designed the motors top to bottom in-house after doing an exhaustive industry search, not finding what he wanted in terms of energy density and peak power and weight. So that was another significant contribution, I think, to eVTOL technology and to industry at large, was actually the motors that were developed in-house. And since then, the industry has come a ways, and there are motors that are pretty close to performance of the original Blackfly motors now. Over time, they continue to evolve the design. They did a lot of work with a subscale aircraft that looks a lot like the Blackfly, but is only about 2.5 feet long. And it was nicknamed the Mini-Me. And that's how they developed all the initial control law for how does it fly effectively as a multi-copter in hover flight, and then how does it transition to forward flight and deriving all that lift from the wings and flying very quietly and very efficiently in cruise, as we call it. Around 2018, I think, was really the first time the company revealed what it was up to. And they did
that was still a long time ago.
Yeah, it was. And it's evolved considerably since then. But that was the very first time that there was a YouTube video with, someone up and flying in a Blackfly vehicle. It was the V2 at the time. Had a bubble canopy, and the fuselage looked like a kind of a pair of chopped off cones that were put together. It wasn't terribly aerodynamic, but it served its purpose as a developmental vehicle, to be sure. Those are the very first human piloted flights. Fast forward just a little bit more, and the company introduced the V3. And the V3 is very close to the current outer mold line that we have today, and representative of years of developed control law for the vehicle. And control law is incredibly important to us because it really gets to the core of what's different about the Blackfly and the Helix versus really every other kind of personal eVTOL that's out there.
The Helix is your new vehicle.
The Helix is the new one that's we've launched the portal for ticket reservations, and we're going to be shipping that this summer. It's the production follow-on to the Blackfly, which will always be our developmental vehicle and pre-production vehicle. As we evaluated it in all possible environments, we also realized we needed something we could scale with in manufacturing a little more robustly. And So the Helix is a very different aircraft in terms of its construction, but in terms of how it looks, what that outer mold line is, what the aerodynamics are, what the control law is, it is a very close cousin to the Blackfly. So
can you talk a little bit about where this fits in the category? eVTOL, of course, is electric vertical takeoff and landing, because these things go straight up and straight down. Can you talk about where it fits in the grand scheme of it being a powered ultralight and so forth? And for anyone who doesn't understand that this is not an air taxi that's going to carry a whole pile of people.
That's right. I'm glad you brought that up, Chuck. So the Blackfly and the Helix are personal air vehicles. They are designed to seat just the pilot and to take them from point A to point B and offer the opportunity for vertical takeoff and landing. So you can rise straight up from the ground. You don't need an airstrip. You don't need a runway. You don't need an airport. You need a clearing big enough and free of obstructions to be able to take off and land. And we guide 100-foot diameter clearing is adequate and safe for just about all conditions. And then you could fly 20 minutes or 20 miles with the current battery technology. And you could use that time to take in the scenery. You could use that time for a short commute or for any other non-commercial purpose that's permitted under the FAA's Part 103 regulations. So what Part 103 is it defines what is an ultralight vehicle. So the FAA has created this category of lightweight, one person carrying aircraft that they call ultralight vehicles. And it's got a very stringent weight limit and a speed limit. And obviously you can only carry one person, but you actually don't need to have a pilot certificate to fly an ultralight. The FAA encourages everybody to be properly trained to fly anything. We absolutely require it. If you're going to be a buyer of a Helix, you have to go through our training. And our training right now is 2 weeks long. And we also require that you have either completed an FAA ground school or have the endorsement to take the FAA knowledge test already in your back pocket before you start our 2 weeks of training, because we want good airmen.
Yeah, I've noticed, by the way, in this whole industry, it's not just the FAA talking about safety, but every single company I've spoken to, safety is just like top of mind for basically everything.
It has to be. It absolutely has to be, Chuck. No one's going to be successful with this new technology if it's not safe for the operator. And if it's not safe, people aren't going to have a wonderful time using it. And that's really what we're all about. This first vehicle, the Helix, the first production vehicle, is all about recreation and short hop travel.
So you've flown this?
I have.
Tell me what it's like.
It's life-changing. First of all, when you're getting off the ground, the closest thing that I would associate with it is being in a Tesla Model S and doing ludicrous mode, because it really gets up and goes off the ground when you do that autonomous takeoff, and it feels exhilarating and exciting. And you see it on all the cockpit videos. This huge smile just erupts on everybody's face the first time they take to the sky. And then in forward hover, you're cruising up to 30 miles an hour, and it feels solid. It feels responsive. It that feedback from the joystick to the movement of the aircraft in your body is just really tight, and you feel absolutely in control, and you feel like you have the freedom to move in all three dimensions. It's hard to explain. And then finally, in cruise flight. So cruise flight is actually where the vehicle becomes very efficient. It actually pitches forward all the way, so the wings are now parallel to the ground, and the motors get remarkably quiet. And when you're pitched all the way forward, you have this unbelievable commanding view of the landscape and the world around you, much like if you were in a helicopter, and right up in front, glass canopy. But the thing you hear the most is actually the wind, and then you also hear the motors spinning up and spinning down, but they're not at all loud. And the closest thing I've experienced to that is actually parachuting when you're about 400 feet above the drop zone. But it's different because you stay up there and you can go anywhere you want. So it's really a powerful experience, and I've had the privilege to do it 16 times now, and look forward to the 17th.
So is the first time and the last time the same, or do you just get more experience over time?
Well, so the training that we do is progressive, and it's performance based. So in other words, you'll have a task to complete, and this is whether it's in the sim, which is you're always in the simulator for the first several days of training is 100% simulator work, or whether you go in the aircraft, you step through a series of tasks, you perform them to a certain standard, then you land, and then you go on to the next flight. After some back briefing and some feedback from your ground instructor. So, but every flight's a solo. You don't have an instructor sitting next to you. So it's all you. And that's why the confidence that we build in the simulator and the proficiency that we build in the muscle memory that we build is so important. We feel to making sure that the operators are going to have, number one, a safe, number two, a really enjoyable experience every time.
So do you have any sense yet of who's going to be buying these? I know that in this marketplace, this is the big year for powered ultralights of any flying vehicle. This is it. This is where it's at. And I have flown one. I know what you're talking about in terms of the experience. But your vehicle is really cool looking. I mean, it's enclosed, like they aren't all enclosed. Can you talk about that a bit and what you see people doing with them?
In terms of what people are going to be doing with them, we're very hopeful and optimistic that they follow their training and they follow what the requirements are of Part 103. So it's not supposed to be used for any sort of commercial purpose. So there shouldn't be anybody out there doing banner towing or land survey or real estate surveys. Those are all commercial activities, and that's not what ultralight flying is all about. Ultralight flying is about recreation, and it's about access to aviation for everyone. And that's what makes it very unique, actually. And in terms of the folks that are showing interest or lining up to purchase Helix, it's an interesting mix of folks. It's really all walks of life, but in general, I'd say it's kind of our sweet spot is between ages 40 and 60, about four males for every female. In terms of hand raising, I'm interested, I want to fly. And generally people with a little more walking around money, because it is not an inexpensive asset, to be sure, but it's also considerably less expensive than a general aviation aircraft. And the cost of ownership is a very, very small fraction of any aircraft.
What does that actually look like in terms of ownership? Do they have to do any maintenance, or you put it in your garage? What do you do with it?
Well, we're looking for you want to store it somewhere where there's a degree of climate control. You don't want it, outdoors. You don't want it sitting in a 110-degree shack in the sunshine. That's bad for battery life. Similarly, having it sit somewhere not climate controlled in a deep freeze is also not particularly good for long-term battery life. So someone that's going to be able to garage it with some degree of climate control. The maintenance is almost nil compared to a regular aircraft. It is actually nil. The motors last the lifetime of the aircraft. They've been extensively evaluated for just that. We've had hundreds of life tests on motors from various lots of manufacturing. We build them in-house. The only wear items we have are the hardware around the canopy that you interact with, all those moving parts. We've seen those get banged up in test flights before. There is we call it a keel strip. It's a wear surface that's on the bottom edge of the aircraft. That if you're doing a lot of takeoffs and landings from concrete or from asphalt, that will tend to wear over many dozens of flights, and that's a replacement item, and actually can be replaced by the owner. And occasionally, folks will land in unimproved areas, a grassy field that's got some little rocks on it, or they'll have a sudden crosswind, and they might sit down, they might break or crack a winglet. Not a critical to flight safety type of damage, but it's something that can be broken and can be readily replaced by the end user.
So with a company that's
Also,
been around since this long, why are they taking off now? Like what happened in the marketplace? Because like this is the year.
well, this may be the year, and there's certainly a lot of buzz in the market about eVTOLs generally. But the reason we launched is because the company and the aircraft were finally reaching that state of maturity where it made sense. And we don't know yet if the market for personal air vehicles is ready. We'll know that a few years down the road. It may prove to be a slow climb, or it may be more demand than we can possibly keep up with. So that is a tale still to be written for sure. But in my early days at AeroVironment, I was very close to those early days of the current EV wave. When the Nissan Leaf was going to be the very first electric car to really go into the mainstream and sell in the tens of thousands in the first year. And as it would happen, it took a little bit longer than that. But then we did ultimately see amazing levels of adoption, and a lot of that happened because the cars got cooler. Well, that's part of what we want to deliver, is make sure that we've got a really cool air vehicle that people are going to have a great time using.
So over time, these things that they all go for roughly 20 minutes because of battery technology. Obviously, over time, does battery technology change? Does it start to be 30 minutes, 40 minutes, that sort of thing?
Yeah, absolutely. The battery technology will enable a helix scale vehicle to fly much longer than it does in not too many years. But you're absolutely right. The energy densities are getting better out there, and they're getting better for the same dollars. And we all have the EV industry to thank for that, because they're really pushing battery technology forward.
So for companies like Pivotal, is this a global thing? Is it a regional thing? Like where are people gonna, like, could someone on the East Coast buy something from the West Coast and not worry about it?
Well, anywhere in the territory of the United States, so 48 lower states and also Alaska and Hawaii, you can acquire a Helix and use it anywhere in appropriate airspace in the 50 states. If you cross international boundaries, now you have to abide by the rules of that civil air authority. And in the ultralight space, it's a slightly different story for every country. So when you get into larger type certified aircraft, there's reciprocal agreements between states, and it's okay to fly your U.S. registered Cessna 172 down to Mexico and back and so forth. In the ultralight category, it is a little more complex, and they are shorter range and lower altitude aircraft, so that's generally a manageable thing. But we are absolutely looking at non-U.S. markets for Helix and derivatives of the Helix, because actually the rules are a little bit different depending on where you are. So in Germany, for example, the Civil Air Authority in Germany has enabled an organization called the DULV, DULV, to assess airworthiness and issue permits for the operation of a long list of different vehicles other than type certified aircraft. So gyroplanes, gliders, motor gliders, powered parachutes, and what we know as ultralights. They all fit into a category they call microlights. And based on the technology that's implemented, they've got different requirements. And they're going to be evaluating the Helix in the coming years. And we've got a similar investigation that we're going to be kicking off with the Australian Civil Air Authority and also Transport Canada, which is
Australia's a hot market.
Yeah, Australia and New Zealand both have a lot of utility for a microlight that is an eVTOL and not dependent on airports. Everything, and by the way, since it's not a FAA ultralight at that point, it is actually a permitted aircraft, microlight aircraft, that's registered. It is not limited to this pure recreational utility in a place like Australia or New Zealand. There's actually a lot of interest from sheep herders, so I've heard.
So you've been doing this for a while now. What surprises you as you go along this? Anything?
Oh my gosh! Well, if by a while you mean the 20 months that I've been with
Yes.
Pivotal,
like is it like today? Is it what on your first day versus today? Is it the same viewpoint?
it's we're a very different organization now. The company has been for over a decade very, very focused on perfecting the aircraft, perfecting the aero architecture, ensuring that there was really robust controls so that we would have a platform that we could first deliver a personal air vehicle on, and hopefully deliver other aircraft for other applications and other sizes down the road. So again, what the company has is an architecture. We call it tilt aircraft eVTOL. And what's so special about that is we've taken a problem that's typically solved through mechanical means, rotating wings or rotating motors, and lots of them usually. And we've solved it with software and controls. So the result is an air vehicle that has far fewer moving parts, lower weight, fewer opportunities for wear out and failure, and a net improvement in efficiency. And just for a lot of reasons, that simplicity, that elegance goes a long way. This is an aircraft that has 12 control surfaces. That's the RPM value on 8 motors and the position on 4 elevons. If you look at and study any number of other winged transitioning eVTOLs, they're exceedingly complex. They're beautiful engineering, but there's one I stopped counting the control surfaces at 40. And yes, it is a bigger aircraft, and yes, it does carry 4 people, but it's complex. And we think that simplicity delivers some real advantages in terms of safety, in terms of reliability, and ultimately cost, and how simple it is to operate.
In terms of categories of flying vehicles, we've got the ultralights, and you've got the air taxis, of course, and then you've got the certified individual flights. This obviously is the year for the powered ultralights. Is that the logical play for all these businesses are different, of course, and there are many of them. But the only one that can really sell anything is this year are the ultralights, really.
That's exactly true. If you're not in the ultralight category, then you're a certified aircraft. And so far, there are no certified aircraft that fit into the eVTOL category, with the exception of some conventional aircraft that have been refitted as electric and or hydrogen powered. There are certified aircraft in that category, but not in the eVTOL category. And all of those, the larger ones, which are destined for this kind of air taxi model, are all what's considered powered lift. So they're using the primary propulsion motors to lift it in vertical flight, and then they transition to horizontal flight wing-borne, getting the benefit from lift from the wings. And that's architecturally what Blackfly does. Every other aircraft that's in the ultralight category that I'm aware of is actually a multicopter. So right. In other words, which is technically a rotorcraft, not a powered lift. So many smaller props that are doing full-time lift, either at 4 points or 8 points. Some of them have 2 motors stacked on top of each other as a coaxial presentation of thrust, but they all work the same way a small portable hand-launched drone does. Multi-copter drone, it's all 100% differential thrust. There's no wing-borne flight.
Isn't it a fascinating industry?
It is well, I think the thing that makes it fascinating is distributed electric propulsion. And that's, really, and very dense, high energy motors is what's allowed this proliferation of aircraft designs that have, many rotors or have a powered lift and do this kind of transitioning move. It's all enabled by electric propulsion. And it's fascinating to me how many different variations the industry has come up with in a fairly short amount of time. I mean, really, all of this started around 2010.
That's a long time ago in the space.
Well, maybe it is, but it's also been 120 years since the first manned flight, and look how far we've come in 10 years with just eVTOL. So I think it's a pretty exciting time.
So last question: a year from now, we're sitting here having another conversation in this space. What will we be talking about?
I think we'll be talking about all the amazing things that the early adopters are doing with light eVTOLs like the Helix and others, in the US and around the world. And I think we'll be talking a little bit about what's next. I think we'll also be talking about some of the other utility that Pivotal has found for tilt aircraft like eVTOL in maybe defense applications or maybe public service applications. I think that there's a lot on the horizon, and we'll have a lot to talk about a year from now.
Well, I look forward to that conversation. Thank you, Ken Karklin, and thank you all for listening to the Voices of the Internet of Things. I'm Chuck Martin.